Right.
Thanks.
All right. Welcome back, guys. I don't know if it's the recording.
We are recording and we are good to go.
Okay, can you see my screen?
Your screen has just gone blank temporarily,
Yeah.
but I saw you were on Jupyter Notes.
It's flickering here. Let me stop sharing and then try again. Okay. I hope we all got a chance to look at the rest of the content from yesterday. I don't know what's happening with my screen sharing here.
Didn't the cold starter affect your computer a little bit there?
But it was working before I started sharing. Let me see. Let me take it out. It's only when we started recording that it flickered, because it looks like it's changed even my resolution.
So let's stop. I just want to stop recording.
Anyway, whilst Langton is doing that, can I share something I realized today?
Sure.
Okay, so yesterday it was a bit hard for me to follow because I was using my computer, my laptop only. But today when I was practicing, I was watching the video from my phone and executing the instructions from the laptop. So it made it a bit easier to follow. So it was just a learning curve for me, because yesterday I had a hard time following because of trying to switch between the windows.
I see. All right.
I must say that's actually a very, very valid point to actually bring up. So obviously in the world of programming and coding and everything like that with data science, having dual screen, dual monitors is always very helpful. Me personally, if I could have 6, I would have 6. It would make my life a lot simpler. But what you said is so.
Yeah,
what you
yeah.
said is true, though. In this process, there is a bit of a learning curve inside data science itself. And I mean, if everyone could do it, then we wouldn't have wonderful classes like this, if you understand what I'm saying. So sometimes
Yeah.
that learning curve, that challenge is what drives us to see how we can improve our code and become even better at what we're doing.
Yeah,
I think it's actually a very valid
for
point that you
sure.
brought up.
That's for sure. Great. Thanks, James.
It's exciting
All right.
times.
All right. All right.
It is.
What I've done is I've moved to my machine from the cloud. The environment is definitely not the same, but I think for us to have progress, I've had to do this. I am not 100% sure why this is, but let's manage it as it is. So if we go back, maybe to just quickly recap. The exercise we did yesterday, we looked at quickly the definitions, where we're looking at these 3 formulas and how we get to where we are now in terms of machine learning and data science. And we looked at the base of our machine learning canvas and an example for the use case that we're working with. So as we were saying yesterday, this is just to get us to answer the why. Because we need to understand why we are doing what we're doing. It's not just to be excited to build these models. And then from there, I think part of the examples, like the work that we actually did yesterday, is we went through the definitions. Everybody was able to set up a core lab on their machine. We're able to install PiCurrent and data prep. And from data prep, we were able to actually load our data from the GitHub repo that I'd set up. And we were able to create the report by just using those 3 commands. And why I was saying for exploration, this is quite important, because we all need to understand why sort of the data that we're dealing with. So this would represent me walking into a new organization. I'm given a new data set. I need to build a model from there. I need to understand the data that I'm working with. But once I've got that understanding, the next step is we're going to get into the feature engineering, which is most of what we're going to be doing today. I'm not sure why Colab is doing this, but I'll continue. Which is what we're mostly going to be doing today. So if we look at the data columns that we've got about 35 columns, and we looked at what skewedness of the data is, correlation, if there's any missing values. So the reason why I kept on talking about those things is generally in machine learning, most models, they do not work well with missing values. So if you've got nulls in your data, that needs to be handled. I saw a comment yesterday. I just didn't want to attend to it yesterday, but today is, I think, the answer. So if you've got missing values in your data, you're going to have problems. Your model will not give you the results that you want. So there is a stage in terms of feature building where you have to handle those things. So depending on the method of building your models that you're using, you would have to handle that, so say probably in code, or you would have to do that in an automated way. So remember, I said we are using PiCurrent for our labs. The reason we got PiCurrent is one of the open source tools that allows us to build machine learning models in an automated way, which means you do not have to do a lot of the heavy lifting that you would normally have to do, say, if you're building your model from scratch in whether it's Python or it's in R or any other language that you use to build your model. So we are gonna, I think today we're gonna spend a lot of our time working with PiCurrent, but precisely coming from where we understand our data and we know what we need to do in terms of building our features. Now, I wanted to spend a bit more time. Is it possible if everybody logs off a Colab so that I can see if it's just me or?
Okay, I'll log off, but I don't think it's just you because I had a hard time.
Is it? You also? Yeah, but I guess if we're all there, it can actually cause problems. So this is the link to PiCurrent. The documentation is there. The module itself is one of the leading modules in terms of automated machine learning. So based on that, what we are doing today is we've got our data set now sitting in a data frame. Let me see if I've got all the modules on my local machine. Otherwise, we will not be able to work with this. So once we've got our data set in a data frame, the next step for us is we've got our report. We are doing the feature engineering now. Now, for any experiments that we do, we typically set up, if it's an automated way, we set up, so you're sort of providing parameters. Okay, I think there's someone who's trying to join, James.
Can't see anyone from my side. All participants are in.
Okay. So we would set up our experiment. So I've called my experiment EXP CLS. Remember, we said this is a classification use case, and I've just given it a 1. So you could name it in any way you want, but at the end of the day, it needs to be something that's a bit more descriptive, because if you are monitoring all the experiments that you're doing, you need to then at least understand what each experiment represents. So when we're talking of experiments in terms of machine learning, remember we said this is not a perfect science, where we're looking at those 3 formulas, and then we went now to then say, now where we are with machine learning, it's not a perfect science where if you put in your money today, you're gonna say, I've got a formula, I know in 10 years it's gonna be so much, maybe based on interest and any other computation that you might have to put in there. So you are experimenting, which means when you've got your training data, you say, look, let me try to train a model using these parameters. Can I limit, let's say, my features to only these 5? Let's see what sort of performance I can get. So you are doing experiments up until you get to a point where you are satisfied with the model that you have built. That is the model that you then take into production. So for our experiments, we are saying, if we look in our data, the data is exactly our data frame. So if you remember our data frame, we had called it data, and then we are saying the target for our model is attrition. So we already have a target column. If you remember the column target, which already has, which is already the yes or no in terms of, sorry, let me just show it here. In terms of the value, sorry, I think I went to the wrong one. I want this one. Pie chart. So it's a basic yes and no. So that is the target column. So we are saying we are providing you a data set. In our data set, we already have a column that tells us that this person left the organization. Now, if your use case is different, let's say you're looking, if we go back to the cancer use case that we were talking about yesterday, you could have a scan image that says this person's scan represents a person who was diagnosed with cancer, and it's either a yes or a no that this person was diagnosed with cancer. So we are using that data set now in terms of us to then say, based on the data that we've got in our data frame, our target column is called attrition. I've just given it a session name. This is just something to just make my session unique. Normalization. So when you're talking of normalization in data science, without getting too much into detail, you will have numbers that are, let's say, the depth of your numbers is variable. You want to represent them, let's say, in a number that is between 0 and 1. How do you do that without distorting the value that you actually have in your data set? So I'll give an example. You might have values of, let's say, 10, 20, 30, 40, for example. If you want to represent those and you say, look, because I don't want to have that high cardinality in terms of the values that I've got in my data set, let me apply normalization. You will have a value after your normalization that is saying 0.1, 0.3, 0.4, 0.5. The context of your information really hasn't changed. If you look at the values that you're taking into account, nothing much has changed, but you are normalizing your values. You're trying to avoid having a very sparse distribution of your attributes. So that's one of the things that we do in terms of building our models. Transformation, same thing. Ignore low variance. So remember yesterday we were talking around when we're looking at our values to then say sometimes you might find there are values where there's nothing unique in those values. The data represented with those values, they are all ones, for instance. So that column is not going to be of any use in terms of building our model. Or you've got a data set where there are probably just two attributes in there, and it really doesn't help us in terms of us building our model. So we are now then saying, when we are building our model, go and remove any of the features that have a low variance. I see there is a hand up, Titi.
Hi, Langton. I just wanted to ask, when you're saying normalize, is it the same as like applying like a log or something, like to reduce?
Yes.
Yes. Like something of the sort. Okay.
Yes.
Nice.
That's it. Exactly.
Okay.
Sure. Yeah.
All right. Thanks.
Sure. So when we low variance, I think we've already spoken about it. So the issue here is, the reason why I've chosen PiCurrent is it's already automating a lot of things that we would have had to do manually. If this is done installing, I will show you the other way that we could have done this. I don't want to restart my kernel. I don't want to restart my kernel. Okay. I'll continue. If this is done, then I'll go to my, I think we're done here. Let's see. Okay. I think Google doesn't want us to share their space. Yeah. can see they've closed this out today.
Oh,
Anyway,
okay, that's fine.
yeah, it's fine. So I'm gonna run it on my machine now. Okay, I'll ignore this one because I don't have that. Clear this output. What I will do is I'll come here. I'll run this. Module compound against that. Okay. Right, so these are some of the things that you have to face when you're building these things. And I think because I moved from the cloud to my machine, I'm already getting a lot of module issues here. Anyway, let's continue. We'll get to it there. Multi-collinearity. So this is the same thing. You might have two variables in your data set that are related. I think in our data set, we already have that. It must be, I think, years of experience, and I think years in a company. So if those two values are the same, you do not need to bring that feature into your model. So remember, the reason we're doing all of this is we need to then select only the features that are necessary for us to build our model. If we bring everything that's sitting in our database, you'll find you have a model that doesn't make any sense because it won't perform well in terms of the use case that you're trying to build against. The threshold is just to...
Sorry, Lanton.
Yes.
Sorry, Lanton. I closed out my collaboratory. I literally closed out of it, and I've tried to log back in, and it's allowed me in.
Is it?
Yes.
Okay. Let's see. Okay, whilst it's doing that. Oh, magic. It happened. All right, maybe let me not disrupt it whilst I'm still talking, and then when we're doing the practical, we just go into the practical. Let me just continue talking. So I'd set my notes for the day here, and everything was sitting in the cloud. That's why now I was getting a bit worried, but anyway, it's fine. So we were talking around the parameters that we've got here in terms of our setup. The log experiment, there is a module called MLflow. So MLflow allows us to manage the whole machine learning lifecycle, in the sense that it's a platform that we can use to deploy our artifacts. Remember, we created a folder for artifacts. We created a folder for data. So MLflow allows us to manage that. And then in terms of actually deploying the project, so when we do our experiments, we need to track everything that we're doing and the parameters that we're using. So if Langton is working with, say, I'll say Shingi, we are part of the same team. I'm building, let's say we're working on the same project. If I do my own experiment and I get a certain, say, performance, let's say under my area under the curve, Shinga might then ask, so Langton, how did you get to this result? I'm quite keen to understand what sort of parameters you used in your model and what features you used in your model to get to this result. So when we've got a central place where we are logging all the work that we're doing as experiments, it allows us to actually have that sort of area where we can review. It's a registry where we can store all the models that we actually develop. So you can imagine if by chance, let's say I develop a model and then it hits let's say 98% performance, and then during the day I think no, let me just tweak 1, 2, 3, 4, and then I tweak those things, I all of a sudden get back to 90. If I do not store the work that I have done when I go to 98, you can imagine, I think most programmers, we've been there where you develop and then you change something, all of a sudden you realize that you've messed up something, you need to go back to a version that was working. If you do not have somewhere to store all that work, you will have issues. And typically in an organization, these are some of the things under governance that you need to actually have in place. You can't just develop on your own laptop and then nobody else has got sight in terms of the work that you're doing, the performance that you're getting in terms of your model. So MLflow allows us to do that. And when we are in our when we are setting up our environment and when we say log experiments true, it knows exactly where that we want to store the performance of our model. And when we say, we give it now a name in terms of now to say this experiment is going to be called 10 over. So when we get into our dashboard in MLflow, we would then be able to see the different experiments. I was trying to see if I can show you something quickly there under that name. So the reason why I started showing you this is I wanted to take us back now in terms of the work that we did yesterday. So if you look, I think we already spoke around missing values. So if you've got missing values in your data, remember we said most machine learning algorithms are not capable of dealing with missing values. So what do you do at that point? You then start speaking to your data engineers to say, guys, give me back this data, make sure that everybody's got for instance, an age. How do you handle that at the time that you want to train your data? So there are several ways that we can mitigate against, let's say, missing data. One of them is imputation. So you can impute your numerical columns by taking a mean. But remember, we understand that the data is really missing. So how do we get around that? Because our model is definitely not going to perform. So we can say, let's take a mean of that column. If it's age, and you've got, let's say, maybe 5 of your guys out of 10,000 that are missing their age. How do you get around that? If you can't calculate it maybe based on an ID number, you say you don't have even have the ID number, you would rather say for those 5 people, for me to not lose that data, let me just get a mean from the whole column and then I'll allocate where there's a now. So that's one way of dealing with it. For categorical columns, there are so many other ways of handling them. You've got mod. Mod uses, let's say, the most frequent value. If you've got, let's say, a data set that's got, let's say, like now we've got employee, it's an HR data set, and they're asking around, let's say, you've got nows in, let's say, residential town, for instance, and it's just a few of them. How do you handle that? You could go and say, look, where if everybody from the data set is predominantly sitting in Johannesburg, you might as well randomly assign Johannesburg to those missing values. But you are well aware that this is introduced because you've got issues in the data. How do you handle it? Because your model is definitely not going to perform well if you leave the nows there. So the way to then handle this now is in terms of the setup. Remember, we're talking around the setup. Using PiCurrent, all you would then do is you would go there and add a new line. We are saying for us, if we want our model to do numerical imputation using mean, we can go there and say that, and then we say comma. So now we are now at that point where we are telling PiCurrent how we want to select the features that we're going to work with. So if you follow, the reason why we started with data exploration is for us to get to this point where we understand if we've got missing values anywhere. I see a hand, Shingi.
Good question. Why not exclude the data? Is it considering the fact that, you know what I mean, it will skew the data?
Yeah. So that's precisely the point. So depending on the severity of the missing values, you then look at, do you really need to sit down? So if, let's say, half your data is missing values, remember when we went to our report here and we asked it to show us missing values for each one of our datas, our features, it was showing us if we've got values that are missing. So that now should then be a guide for you to then say, based on what I'm seeing, I'm trying to see where we are missing values. Where is the red? I saw a red here now. So you can see from all that data set, you've got about 0.07% of your data that is missing missing values on the total working years column. Do you then want to exclude that? Because remember, the more you continue to do your exclusions, you might actually continue to skew your data in a certain way. Would it be bad to infer those 11 columns are on total working years? So it's a decision that you have to arrive at based on the thresholds that you're sitting at. But generally, you want to avoid excluding columns from your, excluding data from your training set, because that might represent something else that is unique that you might miss when you start running your actual inference on real data. Are we good?
Yes, we're good.
Okay. I think something happened today. The screen is, I can't see everyone. So in case I'm missing anyone's attention, please just speak through James, and then I'll be able to control it from there. All right, so that's one way of doing it. So there is another methodology called one-hot encoding. So one-hot encoding, essentially what it does is machine learning algorithms typically work well with ones and zeros. But you will have like as is the case now, we've got gender where there's a female, male. How do you handle that column? Do you do a categorical cardinal encoding? Do you do a one code encoding? So one code encoding, what essentially it does is it creates a dummy variable. Let me see if we've installed everything here. So let me do stuff whilst we are talking. So I'll say, for instance, we've got let's see. I want to see like business travel. I'm gonna do this data. Let me see. I'm pretty sure we're all comfortable with Python. Is that the case? I don't want to be typing code and then people are not understanding exactly what I'm doing. Anyone who doesn't understand Python?
I've never worked with Python.
I'm not well versed.
But
Okay.
It's very logical. It seems extremely logical.
Okay, all right. So that means I need to be explaining what we're doing as we are going. So all I'm doing is I'm trying to just get a feel of this particular column. I've gone to my data frame, which is the data, and I've said, show me just the business travel. I want to do an example. I don't know why this environment is so slow today. Let me alternate between that and my machine. Should be able to do that. For where I need to demonstrate code, I can do that from my machine quite quickly. All right, so I've got that. Let me say, if I say dot unique, this should be a valid. All right, so we've got 3 of them here. We've got travel rarely, travel frequently, non-travel. So for instance, this is a candidate for a cardinal encoding. If you look at the definition that we're talking around cardinal encoding, you are basically saying that this column, I can translate it into a 1, 2, 3, for instance. And I don't really need to have the actual words in here, but how do you do cardinal encoding on such a column? So cardinal encoding, you are avoiding doing one-hot encoding. So what one-hot encoding will do, basically it will go and change for every value within your column, it will create a new feature column for it. and then it will put a 0 or a 1 where it meets that instance. So you can imagine if you've got a column that's got maybe say 20 different values in it, and then you apply one hot encoding on that column. You are then saying from a data set that we've got, which has got 35 columns, you're going to end up with 35 plus 20 new columns. So you continue to extend your data frame in such a way that it ends up not making sense, and your model that you're going to create there is definitely not going to work. So I wanted to show a one hot encoding in Python, but maybe let me just speak to it. So essentially, if I do this, let me try to run it from my machine. Where was I? Do that. So what I will do as well probably is I will explain how, when I'm doing this code, where you can go and find better explanations of how to work around some of these these functions. So if you go on, so we are working with pandas. If you remember, we said import pandas as PD. Yeah, so my screen has been, I don't know what happened. It's actually blown up. So if I'm looking at things in the corner, I can't really see. But anyway, you've got a data set here. You are saying S is your series, and you've got your series, and you're saying based on A, B, C. If you look at this example, so S is the series that you're building, which represents, for instance, one of the columns in our data now. If you say PD get dummies on S, what it will do is in the first row where it meets A, it will go and put a 1 there. And where it meets an A, it will put a 1 there. Where it meets a B, it will put a 1 there. Where it meets a C, it will put a 1 there. So you end up having a column each for each one of your feature values in your data, which then for machine learning, you need to then be careful around how do you build those features. So that's why we were talking around one hot encoding. So you might have a value which is got, let's say, low, medium, high. Those are easy candidates to do that kind of transformation, because you can you're not really extending too many of your columns in your data set. I don't know if we are still together there, or I need to explain a bit more.
We're together.
Okay. Right. So all of these are just approaches in terms of how do you handle, say, for instance, a known level. So you might have a category, as is the norm in any ETL process. Your data is being generated, and sometimes you might get a new feature or a new category that at the time that you were building your model was not known to your model. But you probably don't have a window to retrain your model in that time, but you want to save to get results from that model. How do you prepare for those things before they even happen? So if you wait for it, if you wait for the data to come through, you might start getting funny results and you don't really understand why that is. You handle such things by doing like handle unknown level. So that prepares your model to be able to handle that by putting a default value, which I think in ETL, ETL is mainly for the guys that are into data engineering. That's when you load your data, you apply certain rules. You would say to it, if you are missing a value, or if it's a number and it's missing, replace it with a 0, or replace a date with 19. I think there's a for common 1999, something like a beginning of time or end of time. So how do you prepare yourself where you are not sure that the data that's coming from your engineering pipeline is going to be clean all the time? You want to make sure that you handle such things by putting default values that are able to handle your values. Feature interaction is another thing that we can do as well. So typically, if you've got, let's say, in the sales space, you've got a quantity and price. You might want to get another feature called maybe sales. So that does a multiplication. So that's one way of creating features within your data set. Let me see if I can show that. Are you seeing the transition from us looking at the report and us understanding the kind of work that we need to do in terms of us preparing our features for the model that we want to build? Is there anyone who is lagging behind? We are all happy.
Personally, I'm getting it.
Okay, good. Right. So
I don't know. Is it, sorry?
Mm-hmm.
So what you're explaining here, is it a bit about maybe data cleaning and metadata? Like, I don't. Or is it
Yes
something
and no.
similar or?
Yes and no.
Okay.
It's similar in that, remember, we are saying our data has arrived. It's now in a data frame. We are ready to train. But how do we ensure that the features that we've got have been prepared for machine learning now? So one, we have data that is missing values. We've got data that is not correlatable, that is not correlated, or the cardinality is too high, or we need to standardize the numbers. How do we prepare our data now for machine learning? So cleaning, you can say yes to an extent where we are dealing with missing values, but not really much about cleaning, but it's preparing it for machine learning. And then you've still got a decision to make to then say, based on what I've seen, what columns do I need to include in my model training? What columns should I not even include? So that those ones are excluded from your training. So this is the part now where you make those decisions. But because we're using an automated machine learning framework, most of those decisions would be done for us. All we need to do is to give it the rules to say, no, go and normalize, go and transform, ignore low variance. For numeric values, impute using a mean. So you would have had to run a command where you're doing those line by line, line by line, line by line. But remember, we're trying to make it a bit more understandable for everyone and not go into too much detail of training our models, let's say using scikit-learn, and we're doing it line by line. If we go on that tangent, we find if we're also able with altogether. But at least what we want is to have that base understanding of when we're doing machine learning, we understand our data. Once we understand our data, we need to get to a point where we decide what is important for us to build our model. What sort of parameters, high level, do we need to include for us to be comfortable to then say, look, we have started building our model and we're happy with the kind of output that we are getting.
Okay,
right.
Okay, I get it.
You get it.
Thank you.
Good.
Yeah.
So I don't want to run this. I'm gonna work from what I had done before. So essentially, if we run this setup, what it will do is, if you see, it will give us our session. Our session, we set it to 1, 2, 3, and then it confirms for us that our target is attrition, which is exactly that, yes and no, and it's of a binary, which is just a 0, 1. The label has been encoded. For instance, where there was a no, it said 0. Where there was a yes, it said 1. I think I see a comment there. Yes, so setup is actually from PiCurrent. So what you're saying in PiCurrent, because we have already imported it, we are telling it that in PiCurrent, you've got probably what I could do if I go to, let me just go to PiCurrent on Pi, not here, to explain what it's doing. I don't want it from here, I want it from Pi. This one. Right. So I want to go to the, or let me go to GitHub. Let me go to GitHub. So that question that someone was asking, if setup is part of PiCurrent module. So if I go in here, you see you will have, so maybe let me not go too much into detail, but this explains exactly the kind of modules that are included in in PiCurrent. So if I come here, you will see something like it's going to check metrics. So that's a function. All we are then doing is we are calling a function that is within PiCurrent itself. I think without getting into too much detail, that's precisely what I'm doing. So I'm saying to it, go and do a setup. So this is setup. So setup will go and run certain things. It checks the version that we are running, the modules that we're calling from within it. But because we are telling it, if we are setting up, it expects certain things. It expects a data frame. It expects you to tell it your target. If you're doing a classification case, it expects you to pass in parameters. I could do it without even putting all of this, and then it would go with the defaults. I don't know if you are good there. Right. So after we run this, it will just give us a brief report in terms of what it has done. If it has transformed our data set, if it has shuffled our data set, you can see it telling us everything that it has done. If it's done a folding. So remember when we maybe let me explain it when I get there. Now it might actually confuse you further. If it's done any imputation of types, it will show us exactly what it has done, and the normalization method that it has used, it will show us that. PCA, we're not doing any PCA. So PCA, that's principal component analysis. So we basically, we want, it's reducing the dimensionality of our variables. It's like, I think if you look at everything with data, once you've got the ones and zeros, you want to see how can I compress this data so that I don't have such a huge data set. So it does it's like a hashing mechanism that it does in the back end to then supply that data with the minimal use of memory and RAM, which means the performance or the training of your model is actually going to be much faster. Maybe this might be a bit too detailed, but if I go to something like for instance, maybe grouping features. Sorry, I see I made a spelling mistake here. Grouping related features, and we are saying you've got, let's say, what is a good example? What is a good example? Okay, I'm gonna go for years in experience and the age. Let's say they are two related, and you've got that one company where these two features are related. How do you group those two into one and then get a mean of those two? So you are reducing your features by applying certain sort of features that are common within machine learning, but it builds a sort of a different data frame. I'm trying to look for simpler words to explain it without being too technical. Maybe an example, an easy example is age. You might have a data set where you've got, let's say, you've got, if you look at the age in our data set, you've got, where is age? For instance, if I go to the box plot, if, for example, we had, let's say, a lot, maybe this data was spread out too evenly, you might want to say, okay, can I bin these ages into maybe 18 to 25, 25 to 35? How do you do that dynamically as you're building your features? So all you do is in that setup, you come in and you say bin numeric features, and this particular feature, I want you to bin it, and then it will create those bins for you, so that it's easier. Because at the end of the day, what we want to do is we want our feature to be so easy for us to recognize. Remember, when we're talking about the cat and the dog, the ears of the cat are very distinct from those of a dog. So when you are presenting your data set, it needs to represent a certain picture that makes it very easy for the model to learn and be able to recognize again. You can imagine if we had our age based on, let's say, the actual number of days as well that you are old, and you've got let's say I'm 29 years old, comma 200 let's say 200 days and so many hours and so many minutes. You can imagine trying to train a model based on that sort of level of detail. It's going to be too precise to that point that when you meet a new data set, it's probably not going to give you a good data set. But you've got it already binned, let's say within a 2-year range, and you're saying people within that sort of 2-year range, these are the other common features. It's able to quickly learn and recognize when you show it new data based on that. So that's the reason why we are building these features, so that when we then pass them to our model, we need to make it so simple, maybe not too simple, but simple enough that our model is able to learn. When we then provide it another data set that's got similar patterns, it's quickly going to say, I've seen this before. This is definitely this. So that's the reason why we are doing all of this. Are we good there? Maybe James, you can monitor the chat so that I focus on this and we are able to progress. So
we'll do so.
Yeah, the work for today is a bit more theoretical. Unlike yesterday, I think yesterday we were doing fun things, but we have to get the understanding as well in terms of exactly why we do what we do. Tomorrow, I promise, when we start building the dashboard from the results of the work that we're doing, we are all going to be having fun. So let's just labor through today, and we will definitely enjoy the work tomorrow. So now, once we've set up our experiment, PiCurrent has got another function that's called compare model. So compare models, what it's doing is it creates what is called an ensemble of all the possible candidates. So what it does is it knows that you've got linear regression, cat boost. So these all are different types of machine learning algorithms that can be used in our model for us to get a result. Now, when we tell it that go and compare models, it will go and look at our data set, and then it will try to say, if I train the model using linear regression, what accuracy am I getting? What area under the curve am I getting? What is my recall? What is my precision? What is my F1 score? And then it sort of ranks all the models that are possible. And then it tells you, based on what you've done here, I can see linear regression is leading. So I've told it order by area under the curve based on the use case that we're doing. So I'm going to explain again what area under the curve is in detail so that we all understand what it is. But all we're doing is, you could have now maybe spent a lot of time creating your own model, and you say, look, I believe XG Boost is the best because I've seen in cargo challenges, it's always winning. But if you look based on where we are, extreme gradient boosting is actually not even in the top 5. And you would have built your model based on that and probably get good enough results, and you would still be able to serve results from your model, and you'll be fine. But with automated tool, what it does now, it's going to compare based on all the possible models. It knows that this is a classification use case. It will go and do all the computations based on the metric that we have given it, and it will give us this result set to say, no, based on what you've given me, I can tell you that linear regression is the best. For those of us that are of a statistic mindset, I don't know who else is here today. Yesterday we had some guys who understood statistics. I don't know if anyone else is of a statistical mindset. Was it Lebohang or it was Molefe yesterday?
It was me.
It was you. Okay,
yes,
it was Moses.
Yes.
Okay. Okay, do you mind attempting to explain what linear regression is in simple terms?
Sure. I don't know if I can explain better than you. I think you did a good job there, to be honest.
Okay, yeah, I want to avoid to be the only one talking. But in any case, if you look in statistics, if we are to draw a, you've got your x and your y axis, and you've got a line that's running in parallel there, you are then saying in terms of the distribution of your value, how far close or away are you from that line? So linear regression, it then follows that sort of pattern. If I try to explain it in simple terms, and then you're saying this is the model that we're going to pick to then try and follow that line. But how well off are we in terms of performing, of the model performing? So it will go and pick values based on how far or how close they are to that line in terms of the performance that is doing. But maybe let's leave that to Wikipedia to explain a bit more in detail. So I jumped quickly from where we had done I think our setup to us doing the training. So this part, you find it might actually take you more than a day. If you are experimenting with different models and you're running them, let's say in your own Python environment, you're doing it one by one, you might spend actually more than a day doing just this. And it might not actually be I think worthwhile in terms of your time. I generally choose to work with automated tools first. And then once I've got an idea in terms of, look, I think I'm getting good performance based on linear regression and CAD boost, then I focus on that using either scikit-learn or any other or another sort of module that I choose to work with at that point in time. So here I done a best specific. You can also do a compare and you tell it, don't include everything else. Just go and include linear regression, go and include linear discriminatory analysis, and then it will do only those. I don't know if there's anyone who's got a question here before we proceed. We are happy.
Well, I'm happy so far.
Okay. So what I'm going to do now is we're going to jump quickly to the modeling part. So remember, we've set up our experiment. We have compared the models. Once you've compared the models, I can see that linear regression is the one that is leading. I'm going to create a model, and I'll call it LR equals to create model. So create model is also a function of PiCurrent, which is similar to compare models, which is similar to setup. So I'll say create a model using linear regression, and then the fold. The fold is, I'm telling it, when you're training, you don't want to train to create your model based on just one cycle of running the training. You want it to run a couple of times so that you ensure that as it is shuffling the data, it runs it a couple of times. You are happy that the performance that it's getting it's getting from your model is the best. So it will do that, and you can see it has done. It has run it 5 times, and it will give you where the sort of metrics based on the training that it has done as you are creating the data. Let me not get too much into the penalties and what it means. So maybe let me explain penalty. So when you are training your model, what happens is it's got a point where it converges. So it goes through a cycle, it goes through a cycle, and then it sees that as I'm going through this cycle, when I get to this point, I'm almost getting to the answer. It does the same thing, I'm almost getting to the answer. It does the same thing, I'm almost getting to the answer. So you want to make sure that when you're training your model, you do not quickly arrive to the answer. The reason you would quickly arrive to an answer would be one, either your data has not been shuffled, you quickly arrive to an answer because you have not gone through the full cycle, you have not allowed your model to look at all the options that are available. So you then want to say, what strategy do I implement in terms of ensuring that I do not arrive quickly at an answer, but even if I do, How do I ensure that the model has already sort of gone through full circle by doing those things like shuffling and. So you find sometimes you might get a model that has been trained by, let's say if you train your model by data that is skewed in a certain way, you find that it will converge very quickly. And then when you bring new data now, that is probably different from the data that you've used to train, you see it starts performing badly. Sometimes now the issue could then be maybe the machine learning really doesn't give us good answers. I think that's the default. But it's because when we trained our data, we didn't take enough time to take care of our exploratory data analysis to understand the data very well and implement strategies that allow us to ensure that if we then deploy this model, we are happy that if it encounters new data, it should perform optimally. So all of these things, they're taken into consideration. That's why we're spending our time looking at EDA, feature selection, and what strategies you implement to ensure that when you train your model, you get a good result. So once you've done that, your model would be done, and you can tune your model. So hyperparameter optimization is also then saying, based on the model that I've got, what other parameters can I tune? If you are, let's say, it's easier to look at it maybe from a retail point of view. You might want to say, I've got an algorithm that is doing recommendations. I want it to work to train my model with maybe a threshold of 95, let's say 95%. So I've got people that have got a similar, let's say similar attributes. But because I want to recommend, let's say Langton to watch the same movie that, say, Shingi watched, but I want to make sure that when I'm matching my parameters, let's have a threshold of 95%. I'm not happy if the profile of Langton matches the profile of Shingi at, let's say, 60%. So now you are starting to tune your parameters now to say, let's ensure that we tighten this model to get optimal performance. So with automated machine learning, you do not have to remember what sort of parameters you want to go and tune. It will do that for us automatically. Are we together?
Yeah, I'm following.
Okay. Okay. Once we've created that model, the next thing, remember, we've got now, so I called it tuned model equals to tune this initial model. So I'm now dealing with tuned model. I'll say, now let's go and understand how well the model is performing. So remember, we were talking around, we're talking around the area under the curve. So if you look here, there is a curve that you've got here. The false positive and the true positive rate. Now, when you start talking about false positive and true positive rate, the easier explanation that I can come up with as well is the cancer use case, even the one that we're dealing with now. But let's take it to the cancer use case. You've always got, let's say, 4 possibilities. One, you either have cancer and the model says this one definitely has cancer, or you have cancer and it says you do not have cancer, or you do not have cancer and it says you have cancer, or you do not have cancer and it says you do not have cancer. So your false positive is when you actually do not have cancer, but it says you've got it. The model says you've got it. So now you want to plot your graph to then say, am I covering well the true positive? Am I getting well in terms of the guys that actually have cancer and it actually says you've got cancer versus when it actually creates an error? So if you've got your graph sitting more to the top, it means the performance of your model is good. So that's how you would interpret such a graph. So remember, we are using area under the curve as our metric. So that then becomes the measure that we're doing. And here it says the area under the curve for the class 1. Class 1 is when the person actually left our organization. So it's a true attrition. It says it's 0.88. It's very close to 1, which is ideal. So once you've built your model, the next thing where we are now is to evaluate. You need to look at, is your model performing well? But remember what we are doing. We are logging the performance of our model. So the training that we've taken in, we are logging everything to MLflow. So the performance of our model is the same thing. So similarly, this is a confusion matrix where it says you've got a 1 and it says it mistakes it to be a 0. You've got a 0, it mistakes it to be a 1. It's showing it in a confusion matrix. It's just a different view of showing the performance of our model. Let me pick one. So feature importance does the same thing. Feature importance is now saying, based on the model that you've built, which feature is the most important? So it says years in current role is the most important feature, which means on all the features, if someone is leaving, one of the key features that determines if someone is going to leave is years in current role. So remember, we said on the last day, the next thing that we're going to be doing is we're going to be building a dashboard that we're going to use to communicate now to business to say, for this particular person, we are saying, yes, there is a 99% chance that this person is going to leave. But based on the features of this person, we can see that this is the most contributing factor for this person to leave. Now, if it's years in current role, I think the next thing there is, if we remember, we go back to the decisions that need to be made. It means probably this person has been stuck in the same role for so long. They don't see themselves getting promoted. They don't see themselves transitioning maybe into a different role. How do we intervene? Do we introduce on-the-job training, or do we upskill this person in a different light? Do we move them around? So those are the things that we then need to say, once you've created a model, we get our predictions, how do we inform business? Remember, at the end of the day, the person who is important is the one who's got the money. So that person needs to say, okay, you've got your predictions. What are they telling me besides you giving me a number to say 20 people are going to leave? How do I intervene where I can intervene? So this is now one of the key aspects now when we're looking at our model to say, okay, so this model is telling us the importance of the features is exactly this. So if you look at something like job involvement, if you've got a way of measuring job involvement for someone who's going to leave, they start just not attending meetings, they're not involved in a lot of things, they just always busy with other things. But this depends on if you've got a way of measuring these things. But you can see these are some of the key things that generally lead to people leaving over time. If someone is taking a lot of overtime, sometimes that might actually end up with someone saying, look, I'm overworking myself, I don't have time for the family anymore, I need to leave this job, let me look for something else. So at least these are some of the key sort of insights that you then draw from your model. This one is similar. It's similar to that graph, but here I'm using a PiCurrent function called interpret model.
Alpha, we do have a question coming from the class.
Okay, sure.
I just wanted to ask with regards to the feature graph that you just showed now. I don't know, maybe I missed it. Why is it that you've got 2 different current roles and I don't remember what the other variable is?
Okay.
Yes.
Okay. So remember when we were talking around one-hot encoding? Do you remember the conversation when we were talking around one-hot encoding? And I said what it will do, because we have said to it, go and change our features to make them work very well for machine learning. So what it will do, it will go into our features. So it was one column. It then transposed that into multiple columns now. So you can imagine if it was male, when I gave the example of male, female, it will then say, instead of having gender in one column, let me have gender underscore male as one column, gender underscore female as another column. And then where it encounters a male, it will then put a 1 there. Where it's a female, it will be a 0. But on the female side, it will be a 1 and a 0. Remember, our machine learning model works with 1s and 0. So this is already transformed data. So if you look here where you have overtime underscore yes, so there was a yes, no. It has gone and say overtime underscore yes, overtime underscore no, but it's saying the yes one is the one that's right at the top in terms of importance for features.
Okay. No,
yes.
I get it now. Thank you.
Yeah. Sure. Very, very good answer. I think it has helped me to explain exactly what it does at that point. Similarly, even to job research, you can see director, there is quite a lot of job descriptions in there. So it will then transpose all of them to put 1s and 0s to make it work for machine learning. So similarly, this is just a different way of visualizing it. You want to see in terms of how close we are to 0, what is the influence of our features based on that. It's just a different way of visualizing the same importance of our features. So these are things that if you were to defend or to actually look at if your model is really giving you the desired results, if you get a feature that is here and it's included, but you can see the importance is really 0, you might have missed it probably in terms of how you built your model. This is the time that you can always go back and refine. Remember, this process, it's an iterative process. You do not say, I've built my model, I'm done. You go back again, you do your feature selection, retrain your model again, watch the performance. Are you getting the desired output? Evaluate model comes from PiCurrent as well. So what evaluate model is got all these graphs. So here I was showing you these graphs as individuals. With evaluate model, it will package them in this way. Let me choose one that I know does not cause issues. So you remember our area under the curve is here. If I go to hyperparameters, this is no longer running, so it wants me to run. If I select hyperparameter or all of these metrics, it will actually give us a report based on how our model is performing. Right. I don't know if we are all together. I think let's probably try to finish at past again today, and then tomorrow we will do the fun stuff of building the dashboard and ensuring that we can communicate to our business. I think once we've gone through all of this, what I'll do is I'll try to run it. I didn't want to disrupt it, otherwise it starts throwing those errors again. We'll finalize our model. Once we finalize our model, we'll use our model to do an actual prediction. So we'll say predictions is equals to predict model. I think when I ran this, I had not imported PiCurrent, so that's why it's giving me an error here. And then we'll tell you the data is this. But you can imagine now you might have a new data set that you want to run the sort of same inference based on the model that you've trained. So this is the model that we've trained. We've called it final. I'll finalize my model. I'm saying this is a production model. I'm happy with the work that I'm getting, with the results that I'm getting from this model. I'll finalize it. I then push it to do those predictions, and I can visualize those predictions. So when I visualize, if I done this ahead here, I would then have the original data was like this, and this column was actually a yes. Where it was a yes is our model picking that yes, this is really a yes, or it's missing it. So it allows me to visualize that in this way, and I'm able to save sort of to save those predictions into a CSV file that I can view later or integrate. So you can imagine if you are in a marketing team or you've got, let's say, other stakeholders that you would require to push this result as a CSV file, you could then save this into a CSV file if you're doing batch processes, which then pick it to another system if you're using a CRM system, and then it becomes an input into another process. So here it's similar to what I was doing, just checking the accuracy of the predictions that we're getting. So I can use a util called check metric to do the same thing as exactly what we were doing before. And then I'm gonna save my model, this particular model, into this particular, we call it a pickle file. So when I save it, it then means if this becomes the production model, we can Dockerize this model and run it on our infrastructure as the production model. So remember, our artifacts, they also get stored in MLflow, so that becomes labeled as production. So if an ETL process or maybe an external system is trying to get a result set by supplying an HR data set that meets those column requirements, and it will get saved specifically from that model. As long as it's the one that's currently sitting in production and it's the live one, this is the model that is going to be serving results. But that's one way of doing it. We could still use it to predict on unseen data by essentially loading that model again. So this model that I've built, we could just ignore everything that we've done. If we are happy with it, and all we'll do is just say, no, go and grab the model that is the current one in production, load it in, and we are still able to say predict from, now it will be the loaded model. What is the data that you're providing? So end to end, we've come from, we have done exploration, we have looked at the feature, choosing our features, we've done training of the models, we have done evaluating the performance of our model, hyperparameter tuning, we have predicted. After predicting, we have saved our model, which means that model, if we were to share this in our organization and anyone else is using this, they would actually be able to get the same results from the model that has been approved. So I think that is the work for today. What I will do is I will share this notebook so that you can run it individually on your own machines. I'm scared Collab might behave in the way that it's been behaving, but you will be able to get the same results as I got here. Tomorrow, what we'll do is we are going to then build a dashboard from the output of our model. If we can find time, probably what we'll do tomorrow is, if you can't find time during the day, we'll probably do 30 minutes of just ensuring that everybody's at this level. And then once we are there, we go and build a dashboard. I've set up an environment that's an analytics environment that is in the cloud that we can then use to do a dashboard. At that point, we would have covered end to end in terms of the journey of our data science project. I'm going to stop here and then ask if there are questions, and then we can close for the day.
I personally, okay, go on.
Okay, I wanted to ask on the MLflow part, the logging of MLflow, because from my understanding, MLflow, it basically monitors, it does process that we usually want to do when we're implementing MLOps. How does it come in when we are actually using PiCurrent as we're doing right now?
Yes, so PiCurrent already integrates with MLflow. When you say, I wanted to show, I think my live environment is not up right now. I would have shown you. When you go to your setup Let's go back to setup. Let's go back to setup. Hey. Where was that? It was here. It was here. Sorry. When you tell it log experiment equals to true, PiCurrent already knows that you are using MLflow to log your experiments. So that is part of your configs.
Okay.
So as you train your jobs now, because you've already allowed it and you've told it that log my experiments, it will have all your, sorry, it's just, I said that my MLflow local environment is not working. It will have, remember, we've got the experiment. We've set up our experiment. It will pick up that experiment name. It will have it there as turnover as an experiment, and then all the performance. So as it was training, as we were doing the parameter tuning, it will be logging everything into that environment. So typically, you would then have it, let's say, in a, if you look at most of the organizations, I think because MLflow is actually from Databricks, they have open source, but it's actually from Databricks. You would then have, let's say, an S3 bucket as your artifacts location. So that's just a setup that you do in MLflow now to tell it in MLflow, if you get an artifact that is being saved, go and put it in an S3 bucket. That's the location where that sits. Everything else, it comes with its own Postgres database that it uses now to store as you are logging your attributes. So MLflow just becomes like a dashboard that's then saying, for this experiment, we can see you use these parameters, these were your columns, this was the performance of your model.
All right, that's clear from my end.
Sure.
Thanks.
All right. No more questions.
There was another lady who did want to ask something as well. I'm not too sure where she's gone now.
Oh, that was me. I've put in a comment. I was saying I don't have questions for today, but it's not because I understand everything. I think I'll have more questions once I've tried out the practicals of what you presented today.
No.
So thank you.
Sure. All right. Now, if we're happy, then that's good. I think that the whole point of this is at least to remove the barriers that this is rocket science. Is to make sure that it's simplified. You can see, okay, so this is what is involved. And from here, if you were to then maybe pick up any of these professional courses, you at least have that frame of mind to say, look, if I'm building a use case, I need to start in understanding the why, and these are the blocks that I need. We have taken away a lot of the, I think the heavy lifting that you would have had to do in terms of setting up some of these environments. I don't know if you can still see my, okay, it's not there. If I'd shared some of the environments that I've got on my machine, you find you would have to set up a lot of things to just get an environment up. Farai, I see you've got a hand.
Yes, I just want to ask that for the notebook that you're going to share, what do you need to have installed for it to run? Is there anything else other than Jupyter notebooks that I need to have running on my local machine?
Everything else that you need to do.
Why does it show?
Okay. All right. Great. All right. Noted. Thanks.
Moses?
Oh, can we mute?
Yeah.
Yeah, so I wanted to ask on the setup there. Yes, the parameters that we have set there on the setup. One thing that I noticed with our data is it's actually imbalanced data. We didn't actually put that parameter there. Did it take care of it, or we were supposed to actually specifically tell it to take care of the imbalance?
Yes, we're supposed to tell it. It does certain level of imbalance. So if you look at imbalancing, what it does is what is called, let me show you at the bottom here, what is called SMOT. So by default, it does that. I didn't have to go and tell it to say, go and fix the imbalance. So what SMOD does, I think I did explain it in the past. So it's actually saying that, oh yes, no, sorry, it didn't fix. We didn't tell it to, but it's ready to do it. Sorry,
Yeah,
we didn't tell it to fix. Yeah, so it would have done that. We just need to put that parameter and then we retrain. So already, if you start seeing things like this is where now the performance of the model will start getting better. If you look at the one that I've done for you here, you could leave that on the side, and then you go to all the parameters that are possible. Let's just see that you can possibly do. Let's see if we go to the PiCurrent website, and then I'll say PiCurrent set up. You can set up your environment. Let me just quickly do that. So we've got a classification case that we are dealing with. Come on. Okay, I think I went too far. Let me just go back here. So it says setting up your environment. So already it gives you all the options that you can set. So for things like fixing imbalance, go and understand how do you do that. I think I provided the command for you already. Yeah. It just allows you to do that and then start seeing if there's a difference in terms of the performance of a model or even the actual model that it says this one is the best. You might find that it might actually start picking cat boost as the best based on you have actually fixed the imbalance in your data.
Okay. Yeah. So the other question that I have is back on MLflow. I've never used MLflow. I've used Apache Airflow, but if we're going to do experiments like what you mentioned, that there are different steps and different, maybe you might need to create a data store of your features, all those things, so that you can refer back to the same experiment. When you're doing it this way, are we getting all that logging if I do maybe those major changes and change the experiment again? Do I get them back from MLflow?
Yes, yes, you get them back. Yeah.
All right.
So you just have to reference your experiment and then you get them back.
All right.
Yeah.
Thank you so much.
So. All right. We can call it a night. Is it a day or a night? James, back to you, man.
All right, guys. Thanks so much for everyone's participation tonight. I will be uploading the actual recordings onto the server, onto cloud, so you guys will be able to access this and go through it. So from my side, thank you guys so much for your participation. It's good to see that there is still participation happening in these things. It's the only way we're ever going to learn, unfortunately.
Sure.
I tell you.
Great. No, thank you. Thank you, Langton. Thank you, James. And thank you, everyone.
Thank you.
Have a good night, everyone. Have a